Welcome folks. It's time to continue on with this HEI or High Energy Ignition Distributor series that I've had going on my YouTube channel here for a while. So I'll throw in a few things that I recall from years gone by, and let's get started. Okay, this is the HEI Distributor, as you've seen in my previous videos. I left the screws out of here so we can get this thing apart relatively quickly. One thing more, I should also connect this back up lightly so that we can see where it went from. There we go. Alright, so start off with how much difference and bigger that the distributor cap is on the HEI compared to its predecessor. Up to about 74, this was the size of the distributor cap, okay? And it's almost 2 inches bigger in diameter, not quite. They're both for 8-cylinder engines. Okay, there's the difference in size. It's incredible. The reason they went to a bigger diameter distributor cap on the HEI distributor is because of the higher voltage, and they didn't want, you know, crossfire with the sparks or anything going to the wrong place, so they had to increase the size physically in order to contain the higher voltage that was required to fire the spark plugs, which also had a bigger gap. I should mention off the top of my head, one Oldsmobile I saw with a counter-rotating distributor or rotor inside. It was a low compression engine. It was a 260 V8. Let's see what else. 7.5 to 1 compression ratio right from the factory, as I recall. The spark plug electrode gaps, get this, 80 thousandths of an inch. And that's because of the low compression, I would imagine. But say a gap on these HEI distributors now, generally 45 thousandths of an inch. Whereas if you go back to the stuff that had points and condenser triggering mechanisms in their distributors, well, that was 35 thousandths of an inch. 35 thousandths of an inch was a standard for those, for most of the domestic vehicles in North America. Okay, maybe one more thing besides the size of the cap, the triggering mechanism itself. Up till 74 they used the points and condenser, okay, and on the shaft that was inside the distributor had an 8-point lobe on it. And every time the high side came up, there's a rubbing block here, it would open the points. Okay, only about 16 thousandths of an inch, if I remember, for some of them, whether it be a Ford, a Chevy, or whatever. But anyways, it would just see blip, blip, blip like that, and all it would do is every time the point started to open, let's back up a bit. When they're closed, it charges up the ignition coil, okay, and then once the high part of that lobe comes along onto the points, it would open at that 16 thousandth of an inch, and the second that it opened, the magnetic field in the primary coils of the primary coil of the ignition coil itself, it had a, how can I say it, magnetic field builds up into the primary windings of the ignition coil, and then when this opened, that magnetic field would collapse, and then it would induce its current. And because of the difference in winding turns, a step-up voltage would happen. So depending on what the spark plug needed under compression and the air-fuel ratio at the time would determine how much voltage it would take to jump that spark plug gap between the two electrodes. Okay, so that's old school up to about 74. Just thought I'd throw that in there. One more thing I should add about this. This one was important to have. It's called a condenser in the automotive world. They're really capacitors, if you're an electronics guy at all. And that was there in order for it to, think of it as a small refrigerator that stored many, many electrons, and it had to balance the circuit. If you didn't have there, I don't even know if the car would run, but your points would start arcing and sparking, and there'd be nothing left in a short period of time. Okay, now we got that out of the way. We can start more with the HEI. First of all, let's start taking this thing apart. Okay, there's a connector here. You can see how ugly they can get. You got some kind of verdigrease or some kind of lime scale, whatever you want to call that. I haven't even really cleaned it. It's just an old demonstration one. It's out of a 79 Chevy van, 3/4 ton. It had heavy duty emissions on it, believe it or not, for the Canadian market, and it was very strange. The filler neck in the gas tank, you could actually put a leaded, a larger fuel nozzle from the gas pump with leaded fuel in the old days into that. It didn't have the restricted type that don't take on leaded nozzle, right? So here we go. Let's take the coil cap off of this thing. That's all it is a cap. Nothing special there. Connections for the coil are here, where this wiring harness that I unplugged connects to. and it goes to the ignition module and everything inside there. I'll get to that in a minute. Okay, so these the old points and condenser ones, they were cylindrical coils, and they were generally filled with some kind of oil, or what do they call those, transformer oil of some kind, and that's what kept them cool apparently. This one is epoxy. It's the filling in it is actually like an epoxy resin, so they've done away with the oil and gone this. And this one, I guess it could go up to 50,000 volts if the condition of the engine, the spark plug gap, etc. was calling for that kind of stuff. And like I say, that's why the big distributor cap diameter is in order to control that high voltage that's going through the inside of it, where the rotor's spinning around inside there. Okay, so there's the coil in the cap, as it's generally called with these HEI distributors. Take the cap off and see what we got hiding inside. Let's get this out of the way. There's the rotor. Some high performance companies have actually gone into nylon screws here, believe it or not, because it's a place where it's an electrical ground right into the rotor mechanism and the weight, advanced weights and everything else under there. So they've really gone the extra distance with the aftermarket. Okay, there's the rotor. One thing I'll point out before I remove this to show you the guts of this thing is you'll notice that the rotor tip is spring loaded. Okay, you see there? It moves, right? I can feel spring tension on there, and that's the two springs with the advance mechanism underneath there for the centrifugal advance, mechanical advance in other words. So I've actually marked, I'll take this out of the way, and I've actually simulated a rotor tip with where this thing screws down onto. There's a notch here, so this little protrusion here is what goes in the notch to make sure you don't put it 180 degrees out of phase. Alright then, first thing we should get into here is the very first thing is always remember that a distributor in these conventional North American vehicles always spins, the shaft here spins at 1/2 the RPMs that the crankshaft in the engine spins, due to the 2-to-1 ratio reduction, because of the sprocket on the crank has half as many teeth as the larger sprocket on the end of the camshaft. So it's always a 2-to-1 ratio, no matter how many teeth you're talking, right? Okay, so keep that in mind, that whatever you do here is going to affect the crankshaft. Going the other way, you increase by double the amount. So when you're coming back to through the camshaft and into the distributor shaft, then it's half. When you go the other way, it's actually going to speed up towards the crank. So if you have 1 degree of advance here, let's say, it'll show up as 2 degrees on the crank, with the exception being some of these vacuum advance canisters here, the markings can be specified in crankshaft degrees. This one has a 15 in it, so my best guess is it'll vacuum advance only 15 degrees of total at the crankshaft. So really watch that whenever especially you're talking about anything to do with advancing any whether it's the mechanical or the vacuum advance, whether you're talking in distributor degrees or crankshaft degrees. Okay, so here you'll notice here there's some numbers stamped in these different. These are the fly weights. They basically fly out as the engine. Actually, before I get that far, the weights come out centrifugally. It's just like swinging a bucket of water around in a circle as you're standing in one spot. So the faster the RPMs of the engine go, the more these will start to fling out, so to speak. Okay, until they come to a point where they do not advance any further. Now if you notice here, I put some chalk on this locator for the rotor, but I put some, like I say, I put some chalk here, so what we're going to do is pretend for a minute that is the tip of the rotor. Now everything is kind of locked down here, so if you watch that, it'll actually move this portion of it here, this square plate, well maybe it's kind of a parallelogram, it's actually part of the distributor shaft. It's bonded, you might say, whether they pinched it on there, welded it, whatever. But what this is rotor phasing. So if you advance the spark, I'll show you that later, it's underneath with those 8 triangles, inner and outer. If you go ahead and you get the coil to discharge earlier and you don't advance the tip of the rotor in line with the contact point that's inside the distributor cap, what will happen is that'll get further away from the terminal. So say if the terminal is here, normally in line, and now you advance the spark, right? Okay, so that's going to happen earlier than where that cap actually is, that contact point. So if you go ahead and advance the spark without advancing the rotor tip, what happens? It's got to make a bigger jump, and it might not make it. In a worst case scenario, probably not with the HEI, but it might even go to another terminal on the smaller distributor caps, the old way. Okay, so as you see, this is with the mechanical advance weights. All they do is they go in time with the speed of the engine itself, nothing more, nothing less. Okay, generally speaking, most of these flyweight type distributors, they will be in the relaxed state in the closed position, anything under 1,000 RPM at the crankshaft. So tachometer, you're watching engine RPMs, you're below 1,000. These flyweights will probably be in all the way, so there's no mechanical advance taking place. Once you hit 1,000 RPMs and start climbing, these will actually start to come out, and the faster that the engine spins, the more these will come out and advance the spark. I'll show you that mechanism underneath once I get this thing tilted, but I just wanted to make sure that you knew what rotor phasing was. Mind you, it only happens with a mechanical advance on these. The vacuum advances where you got to be careful. There's no adjustment for the rotor tip with vacuum. So that's one thing, rotor phasing coming. If you're advanced, you'll know what rotor phasing is, right? So there's the advance mechanism. The thing you got to be aware of with these HEIs, there are so many of them made. You can take these numbers down and see if you can find anything on the internet. But the weights there themselves, I wrote it down here somewhere. The weight numbers are 106. The center plate, or what they commonly refer to as the autocam, it has a profile that these weights actually run around on, make contact with. And there's a profile there that will tell you what your the advance rate and the advance curve that you'll get as this thing starts to speed up. So they made many of these. The center plate on this one is, where is it? The 406. So they made many of these for different cars, Camaros, what have you. This one's out of a Chevy van, so it's probably going to be a pretty lazy one. It's a smog engine. Lower compression, maybe 8.5 to 1 compression ratio. So be aware that there's no two the same, maybe the same vehicle, but when you start going into a lighter car and everything, the advance amount and everything changes, right, as well as how much it does. Well, I've got it up here too. You have to know what your total advance is. Now you set your initial advance, say if it's 5 or 10 degrees, wherever you set it. That's what the weight's retracted, nothing's happening. So whatever the amount that these mechanical weights themselves will provide, so say if it gives you, I don't know, 20, 25 degrees, say, from fully closed to fully open, then you add that to the initial timing that you set on the harmonic balancer front of the crank with your timing light. You have to add the initial to what these weights provide. That'll be what they call total timing. Now don't factor vacuum advance into that total timing. It's just an old school thing that I believe that started in the racing world, racing circles. They probably didn't use vacuum advance, so that wasn't really a consideration for them. So when you hear the word total advance, always be aware of who's saying it and what they mean. So get exactly what they want to mean when they say something like that. Okay, for me, that's a pretty standard thing. So total advance is initial, what you set on the damper with your timing light, plus whatever these weights provide. Like I say again, this might only do 12.5 degrees by itself, but you have to double that because you're going from the distributor RPM to the crankshaft RPM. Okay, so it's usually a 2 to 1 increase at the crank, but a reduction when you're coming back the other way towards the distributor. So if that, you could actually measure that if you lock this down and watch the degrees. If you put, like, say, a cam degree wheel or something, hooked it up, you could actually see how many degrees this would advance the engine timing. Like I say, that's a centrifugal only. It goes in step with the RPM of the engine. Now this one, it probably wouldn't fully deploy until you got around 4,000 or something like that RPM at the crank, because it's really lazy. It's a smog engine and everything. It's really slow. So the profile on both the autocam or center plate and how it reacts with the weights, which can weigh different, be a different shape, and then the springs also. Okay, lighter the spring tension, the faster these are going to kick out. Heavier the spring tension, these are pretty heavy springs in here, So it's going to take like forever to get going. That's why I'm calling. Like, I can't find the specs for this online anywhere, but I'm assuming it's at least 4,000 RPM at the crankshaft before these fully deploy. So there's your mechanical part. I'll get underneath of it in just a minute. Like I was saying, these vacuum advances, if you're ever going to change one out, say for a stock factory distributor, make sure you get the exact same one, because these vacuum advance canisters, believe it or not, just well, maybe before they started to group them together a bit more, yeah, this will do that one, so we're going to get rid of, you know, a few of them here and there. But there were so many of these made. Okay, there's three things you have to be concerned with, two of which are the vacuum rating on them when they start to pull the rod and where they fully make the travel. Now that's usually measured in inches of mercury. You can use a vacuum gauge or vacuum pump on one of these. You don't even need the markings. You can figure it out yourself on paper just by doing a few simple calculations. Then there's a total amount of travel of that rod. So if it's saying 15 degrees, which I assume is crankshaft degrees, then that thing would probably move the outer set of triangles half that amount, which is 7.5 degrees. Okay. Another thing I should point out before I put this on its side a little bit, this condenser, aka capacitor in the electronics world, is for radio noise suppression, whereas like I was mentioning before, the one that's on the points and condenser system here, well, it's a very important one if you want to go back into time a little bit. Okay, so yeah. Now we'll flip this on its side. Now I think I've said about the rotor phasing, okay, mechanical advance only, and all the different numbers, and like no two distributors from the factory HEI came the same at all. They're all so different, so you got to be careful which one you stuff in what engine, because you can cause some damage, especially if it's over advanced. You get detonation, and if you got enough things going on, it could even be some pre-ignition too. So I got the old kickstand here. Let's turn it on its side a little bit, center it up, put the orientation where I had half a thought as what I was going to do to explain it. Alright, center it up. Hopefully that'll work. There we go. Okay then. Notice with some white chalk I marked some of the triangles here. This is the triggering mechanism for the coil to discharge. Whenever any of these 2 points are in a line, like there's 8 on the inner set of 8 triangles, and there's another 8 in the set of triangles that are on the outer ones, which are controlled by the vacuum advance. Whenever they align, or go just the inner ones just go very slightly past the outer set of triangles, it'll signal the ignition control module to open the circuit, the electrical circuit to the coil, and that's where that magnetic field in the primary coil collapses onto the secondary windings in the secondary coil, and because of the turns ratio difference, 100 to 1, whatever it is, that'll determine what kind of step-up voltage you get. Generally speaking, that is. There's a lot going on with the science and theory behind all that. Okay, so I'm only going to move one weight here on the bottom side, well, as far as I'm facing it, so this weight won't come out and get in our field of view. Okay, I've purposely put the inner set of 8 triangles approximately halfway between the outer set of 8 triangles, just so you could see the movement and see how this thing works. Okay, I'll get to the ignition module and what it does and how it compares with the points, if I don't forget, that is. So as the engine gets past 1,000 RPMs, crankshaft RPMs, the fly weights will start to come outwards faster the engine goes. Now I'll do it quickly so you can see it without, you know, watching this real slow motion going on. I'll move it open relatively quick to its stop, the advance weight that is, on the auto cam. The inner set of triangles, like I say, it's connected with the advance weights. So you watch that inner set of triangles, which is right here, is right between my fingertips, and the outer ones are right here. So watch what's going on there. Okay, so you see the movement? Okay, so this is a clockwise rotating distributor. The way I tell without even taking the cap off is just pretend you're blowing into the vacuum advance nipple here. and it's like a water wheel or an air paddle wheel kind of thing, and it'll spin that way. If it was an Oldsmobile, they generally spin the other direction, so the advanced canister will be on the other side and it would be going counterclockwise. But this is a Chevy distributor, so we're going clockwise the way the distributor shaft is spinning. Okay, as these weights come out, there's your advance right there. You can see the inner set of triangles moving. I've got everything else locked down pretty much. So you can see that movement there, and also, again, maybe I'm overdoing it, but you got to pay attention to rotor phasing, especially when you're going at higher RPM. Otherwise you start getting misfires and all kinds of crazy stuff starts happening. Let's move something else out of the way here. So there's the advance. Okay, there's where it is its relaxed state. So you're basically, if those triangles would be lining up with each other, all 8 of them, inner and outer, if the engine was just idling on its initial or base timing. Might be, well, this particular one, its initial timing was 8 degrees that was on the sticker under the hood, the engine's hood there in front of the vehicle. You can actually retard the timing a little bit if you want to get a better reading at smog. I think I went with 5 degrees on this one, and it helped out a lot with the smog readings when it was going through back in the day. So there's a mechanical advance. Like I say, it keeps, the advance is what could I say? The crankshaft RPMs will dictate how much this moves. So the faster the crank spins in the engine, the more advance you get up until it hits its stop. Now some of these, the advance weights against the center plate might be the stop, but there's sometimes a slot down inside there if there's that kind of a stop, like the old points and condenser distributors. So there's the mechanical part along with the rotor phasing. Okay, so now you see how that works, right? Okay, now we'll get into the vacuum advance. Now, a lot of people say, oh geez, we've got a race car here. That's fine and dandy. The best thing I've ever heard on the forum is they don't run vacuum advance back when they used to race with the distributors. And one of the best comments I've ever seen is, how many guys have you seen run out of gas on a yellow flag lap, or a number of them, and it'll help your fuel economy immensely, because you've got such a lean air fuel mixture going through there that you need the extra advance, because the cylinder is not being fed very rich air fuel mixture. It might be the stoichiometric, like nowadays with computer cars, 14.7 to 1 is the standard. They found that was what gave you the best burn under light load conditions and at idle speed. And then while I'm at it, if I'm going pedal to the metal in an old school 100% gasoline car, then carburetors, I'd like to see them run about 12.5 to 1 air-fuel ratio. That's by weight, by the way. A lot of people just go air-fuel ratio. Some say it backwards. Fuel-air ratio sounds kind of weird. But the air-fuel ratio is actually measured by weight, apparently. But we never really keep that in the forefront for the most part. We just always seem to just call it a straight ratio. So yeah, 12.5 to 1 for full-strength gasoline. And then if you go back into some of the older Chrysler lean burns, I'm sure they're getting up into like 18 to 1 air-fuel ratio. Anyways, I'll put this vacuum hose on the vacuum canister, and I guess I'm going to have to explain what I'm doing, because my mouth is going to be on the other end of this piece of tubing here to actuate the actuating rod that comes out of the vacuum advance canister. This one, like I say, it's a 15 degree, probably at the crank, so this will probably move if you were going to the center point of the distributor shaft. And like I say, if you had a degree wheel or something, or you'd probably see it move half of that from a radial standpoint. Okay, so this one is a bit sticky. You'll notice at the beginning it'll kind of do a clicky noise, and maybe it'll be a bit stubborn to start, but it'll go. And then what I'll try to do is release the vacuum on it slowly so you can see it come back. And now you want to watch the outer set of 8 triangles. It's a V8 engine, so you got 8 triangles, 1 per cylinder. So it's going to go the opposite way. Remember, the shaft and weights are spinning clockwise. So if we move that outer set of 8 triangles counterclockwise, that will advance the time that the ignition coil discharges that high voltage down the spark plug wire and into the spark plug, electrodes. So here we go. I'm going to move it in the advanced. It can only go one way when you're pulling vacuum on it. Okay, so here we go. So what you saw there was this would be drawn in because of the intake manifold vacuum. It's measured in inches of mercury. Now if a fully warmed up engine, depending on what year you're talking about, well, if it doesn't have a lumpy camshaft, an old stock engine could see about 20 inches of mercury below the carburetor. That's the intake manifold vacuum. Now if you had what they call ported or time vacuum, there would be no advance from the vacuum advance distributor, because basically the throttle valves that are within the base plate or the throttle body of the carb, same thing happens with an air plenum type thing on a fuel injected vehicle. You're controlling the amount of air it's throttled, in other words. So with the ported vacuum you wouldn't get any vacuum advance at idle. Depending on what you're after, there was a big smog thing too. It helped with the smog readings if you didn't have any vacuum advance at idle speed. Some of the older cars, they could very well have had vacuum advance at idle. It'll, for instance, the vacuum can here, 15 degrees at the crankshaft, you could hook this one up to manifold vacuum and the engine would like it. There's a lot of things that go on with it which I won't get into. Each individual engine, as far as I've always thought for years now, is that they're like people. They have their own personalities. A lot of the guys that get really into modifying their cars and all that, they'll tell you the same thing, and they do have a personality of their own. They're mechanical. They almost talk to you at times, you might think, but you always got to make sure that you have the right vacuum advance can on there. Some are adjustable. You'll find some of them, they have a hexagonal or six-sided crimped, what looks like a nut on the end of the vacuum advance canister. Most of those should be adjustable. You just poke an Allen key in through the nipple here that the hose attaches to, and then you can actually make some adjustments with it. Some of the things you can do if you have one that, say, you might want to have it run a bigger cam or something, you can limit here. You can just, solder braze on a stop or whatever. There's even some aftermarket places that companies that have plates to limit the amount of rod travel depending on what kind of can you have, advanced can you have here. So let's see, let's get back to, so now you see how the advance mechanism there works. There's the mechanical, that's just the flyweights along with the rotor phasing, and then there's the vacuum advance, outer set of triangles, and try to explain what the vacuum is basically for someone who's maybe new to the game. An engine idling give you maybe 17 inches of mercury to 20 inches. Maybe some of the older cars could have gone a little over 20 inches of mercury at the idle position in the intake manifold. But when you're going pedal to the metal, a lot of guys, we can't have vacuum advance on there. I really want this car to go fast. Well, the vacuum advance won't even move once you go pedal to the metal on there. The vacuum, like when those throttle plates are butterflies in the carb, if you got a 4-barrel, all 4 of them are open and it's feeding as much air as it can to the engine. The vacuum, inches of mercury of vacuum there, they'll drop to almost zero. Might get maybe 1 inch of mercury, and then if you're higher altitude, I imagine that would be even lower too, because most reference you'll hear is at sea level. There's a little more oxygen down here by the ocean. Okay, so there's the basics of it as far as the advanced mechanisms work, but you got to pay very close attention. You don't just go willy-nilly here. Another thing too, a lot of guys say, oh, I've set my timing with a vacuum gauge. Well, no siree, Bob. You always want to use a timing light, and you always want to make sure, especially if it's an older car, sometimes the rubber bonding where the inner and outer part of the harmonic balancer, that can slip, or maybe it just wasn't accurately done with the keyway or whatever, but you always have to make sure that that's an accurate mark, especially if you're talking high performance. You can use a piston stop, move the crankshaft counterclockwise, clockwise, make a couple marks, and halfway between those marks will be your true top dead center. Okay, so now let's, now that I've gone rambling on about that, let's get back to what actually happens with the electricity. Okay, so Actually, I don't even need that. Okay, you've got the connector going into the coil, so it's once you put the ignition key in the start or run position, it's feeding 12 volts battery voltage, maybe a bit more once the charging system kicks in, up to usually less than 15 volts, depending where the voltage regulator's calling the shots for. And now dwell, yeah, that's it. So the coil is energized on just on the positive side. Now basically what an ignition module is just a really sophisticated switch. Now where's those points? This was a fixed dwell, okay? On a V8 engine was usually 30 degrees, so the shaft in the distributor would turn 30 degrees. That would be the amount of time that the points would stay closed, and that's the amount of time that it would feed electricity to the ignition coil to charge it up. Like I said before, as soon as those contact breaker points open, even the slightest amount, then that stops the current and voltage going to the oil-filled ignition coil, and then you would get that magnetic field collapse and the high voltage on the way to the spark plugs there. Now this is a fixed dwell, so they had to make that coil so it really didn't output as much as this one is able to. You cannot charge an ignition coil for too long, depending on how much voltage you're feeding it. So with these points and condenser systems, they usually had a resistor wire in the GMs. Some of the others, I know the Chryslers, they used a white ceramic block with what they call a ballast resistor in there. So the slower the RPMs of the engine, say at idle speed, they would have to really hold back that the amps and volts that are being fed the coil, or the coil would overheat, be overcharged, just like overcharging a battery, and overheat, and it would eventually fail, and then you would have a non-working ignition coil. Same thing happened in the old days. If you left your ignition key on, say, in the run or start, well, not the start, but you left it in the run position instead of clicking the key back to the accessory position, and if these points were closed, it would keep charging the ignition coil, eventually overheat in a lot of cases, and kaput goes your ignition coil. Now this was fixed 30 degrees dwell, so that's 30 degrees of shaft rotation of the distributor where these points would be closed, okay? If you work out the math, then 15 degrees is basically from the time they started to open and then before they made contact again. So 30 degrees closed, 15 degrees open, another 30, and it just kept on and so forth. Now with these little things, these little brains, they're really quite something. These guys really had their work cut out for them when they had to design the system. Seeing as how there's a full 12 volts going into the ignition coil through the cap connection, they had to find a way to make sure that the ignition coil wasn't being overcharged. Okay, so what they've done is they basically made a dwell control in here, whereas the points was fixed at 30 degrees for a V8. This one, I remember measuring it just years ago. I put a dwell tach meter onto actually it was this very same distributor. I recall seeing like 7 degrees dwell. So this will actually, the charge up time is knocked down to 7 degrees at idle if those readings were accurate. And then what happens, the faster that this thing spins, there's less time for the coil to build up a charge before it can release the high energy, the high voltage. So the dwell would increase with RPM. So you're getting, I don't even know what time it factors in. It might be more than 30 degrees. It probably is. And depending on, everything happens so quick. We're talking milliseconds. The time factor that they're using is milliseconds, which is 1/1000th of a second. Now if you were to count as fast as you could, to say you might make it to 10 before 1 second of time passed. Imagine trying to count to 1,000 in 1 second of time. Now that's some really small stuff right there. So everything is happening in milliseconds with these things. Even the charge up of an ignition coil, it happens really quick, 3-4 milliseconds just off the top of my head. You can look all that stuff up online, but it's quite amazing that these things, these old mechanical things with the rotor spinning around, could actually keep an engine going smoothly, especially when the RPM started to pick up. So that's what this basically is variable dwell, and it controls how the ignition coil is getting charged up. And like I say, when those inner set of 8 triangles pass the stationary outer set of triangles, that's the signal that it's looking for to break the circuit so that it shuts off the electricity to the primary windings in the coil. And here we go again. That magnetic field that the primary windings have built up will collapse onto the secondary coils and then induce a higher voltage because of the turns ratio between the two coils, step up turns ratio. So I don't know if I really left much out. Kind of rambling on here just off the top of my head. We could go into maybe some basic settings, but these are examples only. Don't use them. Okay. Say you have a Camaro, Mustang, whatever, and an old school distributor, anything with flyweights pretty much, whether it's a points and distributor or the HEI style. Initial timing, a good one to start out with if you have a lighter car. Mind you, you're not going to put a heavy trailer on and start towing up steep hills. I mean, when you start getting performance curves for a muscle car or whatever, and it's a lighter car, say 3,500 pounds, ballpark figure, then you got to factor in, am I going to tow a trailer with this? Am I going to, load my car down with band gear, drum kits, all that heavy amps with tubes in them, trailers? If it's just a car that you're going to drive, as your second car, it's fine. You can actually bump up the performance, but you got to remember too, these don't adjust themselves like fuel injected cars. Whatever you do to a fuel injected car, it takes care of it for you. You got knock sensors on the block, back off the timing so you don't get into detonation. But here, I'll get back before I ramble anymore. You could actually set your initial timing. That's the one that you set on the harmonic balancer with a timing light. Say at 10 degrees, right? Something like this, you could use this, but you have to be careful. The amount of timing advance you get out of the weights from the time that they're in the relaxed state to there, you have to know what that is and add that to your initial. So if you have a small block engine, Chevy, Ford, Chrysler, 35 degrees is a good ballpark. Like, don't quote me on this stuff. It's just simple math to help you see how this thing works. So if you have 10 initial and say you had 25 just from the weights there, so you add those two together to get what they call total timing. Does not factor in the vacuum advance, okay? So 10, 25 from the weights, so 10 on the initial, 25 from the weights, you get 35 degrees. It's a ballpark. A lot of small blocks might like it, some might like less, the older ones might even like more. And then as far as the advance, so say if we had is at the 10 degrees initial, plus 25 from the weights with a 35, that's what you'll get pedal to the metal, low vacuum condition, the vacuum advance will not kick in, so you're getting 35 degrees of total advance, okay? So now you factor in another 15 degrees, which I can't see this being a 30 degree can. I've never heard of such a thing. The biggest one I've ever seen is a 20 degrees, so I'd say that's crankshaft degrees. So we've got 15 degrees plus the 35 that we got from the initial plus the 25 here. So we get a total of, what is it, 50 degrees? That's ballpark for a stock engine, lower compression engine, going down cruise speed, not too fast. So yeah, 50, you could even go up as, I've heard of it going up as high as 52 degrees of advance with the total, the initial plus the weights, whatever they give you, plus the 15 from the vacuum advance. Like I say, this only goes when there's a signal, intake manifold vacuum signal that's strong enough to start pulling on the rod. Now there's a mix going on when you're cruising. Say you're going 2,500 RPM engine, 50 odd miles an hour depending on rear end gearing and tire diameter. The weights might be part way out, say halfway. This could be fully deployed. So say we're getting, let's see, say 10 initial and 10 from the weights, just to make the math simple. So we're getting 20 from the total, plus the 15 would give us 35 degrees at, say, 2,500 RPM. Examples only, like I said. You just have to know what you're looking at when you start doing things. Like I say, one of the biggest problems people don't understand is they go ahead and, oh, my engine, I'm just going to give it all this initial. I'm going to give it 15 degrees. Well, don't forget, when you start, well, with a clockwise rotating distributor rotor, then you go against the grain, so to speak, counterclockwise. And they advance it, say, to 15 degrees. So say the base timing was originally at 5, so you put 10 into the initial or base timing. Well, don't forget, that's also going to go from 35 degrees in our example to a 45 degree total. right? If you take it away from its specification, say was it, we'll say it's at 5 degrees of smog, it's a good smog setting was 5 degrees. You bump it up another, you wanted 15 degrees initial timing with the timing light on the harmonic balancer. Well, don't forget, anytime you go out of spec and advance it more than what everything else is going on here, then you're going to be taking that total and advancing it's going to be too much. So always, if it's a stock distributor, always make sure that you stay within specs that the manufacturer called out for that particular distributor model. Otherwise you get into all kinds of trouble. You start getting engine damage and things get rather expensive. And unless you're filthy rich, it's going to sting you in the pocketbook. Okay, so always make sure that you never over advance this thing. If you go a little too high on the vacuum advance, then you'll get what they call trailer hitching or surging. That's one of the first things that shows up if you have too much vacuum advance. And if you don't have one, well, you're going to start fouling plugs here. You're missing out on 15 degrees of additional timing when the engine cylinder is being fed such a lean air fuel ratio, and then along with this era of distributor and vehicle, they were putting EGR valves on them, so that exhaust gas would actually through the valve go into the cylinder along with an already weak air fuel ratio mixture of air and gasoline. So that you could even have more spark advance when you start introducing exhaust gas recirculation into the cylinder. So everything has to be considered before you do any modifications, any adjustment. Like I say, if you've got a stock distributor, always stay within the timing specifications for that exact vehicle. You could, in one of the Dodges I remember back from the 70s, it could said 5 degrees initial timing, plus or minus 2 degrees. So you had a little bit of leeway there, but it wasn't going to harm anything if you went plus 2 degrees on it. Like I say, always do your homework before you just grab a handful of timing and start doing this, especially at the top end when you're going high RPM under a high load, pedal to the metal stuff. That's when the engine damage is really going to start happening. And before I depart, there's one more thing. Where is it? There's each of these distributors actually have a number on them. Okay, so if it hasn't been messed with and everything else is stock and not too worn out, you can try to find the distributor number online, or maybe there's somebody who's kept the older books or whatever for, say, a Sun distributor machine, and you could look up the specifications for that, or you could do it with a timing light or a timing tape on your harmonic balancer, a dial back timing light. Take your pick. There's all ways to do it. But the particular one on this, the number that's on this distributor housing here, you'll always find it usually on a GM will be stamped at just at the base here. Okay, so this one is 1103274. And there's some suffix punchings in here too, BL space with a 2. I don't know what that would be. Anyways, that's about as much as I got to put in this video. It's probably long enough as it is. Oh, maybe I should add this in too. This is a rather important part. With the ignition module, a lot of people, like I even went to a parts guy a number of years ago and I was looking for some goop. Like you have to, on the bottom of this, there's a metal plate on the bottom of the ignition control module itself. It looks like steel or maybe some kind of coating on it. And then there's the aluminum pad in the distributor housing body here. You want to clean them up. I like to use 400 grit wet dry sandpaper, same stuff body guys use a lot. Make sure everything's clean, and never use dielectric grease. You know, it's not made for heat transfer. You have to. Where I do is I get a used to have it here on the workbench, but use the compound that they use in a computer store. Like if you go to a computer store and ask for some heat sink or heat transferring compound that they use on those chips they use in computers and video game units, you know, the CPUs and the GPUs, which is the graphics part of the central, you know, it's the two different chips, the big chips, and they get really hot now with the advancement of how much data they can crunch in a given second. But always use the proper heat transferring goop, because what will happen is if you use dielectric grease on here, is it won't transfer the heat from the module into the distributor body, and then poof, there goes your module. That's probably going to cost you another $50, give or take a bit, to get a new one. And if you're middle of nowhere, you don't want this thing conking out on you. especially if there's no cell phone reception like in the mountains, right? Another thing too is these two screws. I'm going to keep going here. Why not? These two screws have to be nice and clean, and the holes they go through in each end of the ignition module look like they have brass eyelets or tubing that's been pressed in there, right? That's the actual ground for the module. So make sure that where the screws are clean, those brass sleeves that go through the module are nice and shiny and clean, and also the screw threads where these two machine screws go down into it. If everything is all clean, you want a good ground contact for this ignition module. Like I say, the heat transferring compound is the really biggest concern here. Never use dielectric grease or you're asking for trouble. All the connections, bright and shiny. Like I say, prime example here, fairly moist in the winter here where we are. But you can see this connector. I probably maybe showed it to you in a previous video in this series. See all that? I remember the word from when I was a kid, someone called it verdigrease. But it's a green kind of corrosion. I'm not sure it looks alkaline. That can't do any good for anybody, you know, especially when you're talking lower voltage, 12 volts or whatever. You know, connecting to your cap, and then you're just, you know, everything, even the radio interference condenser, aka capacitor. Look at how rusty that got just with the, you know, the humidity that's in the air here. Like I say, go through the whole thing and clean it all up. Shinier the better. One last thing. Sometimes there's a rubber-like diaphragm in here. It's got a really heavy spring in there. Those diaphragms, sometimes they crack, they get ruptured, get an air leak. So if you draw a vacuum on that the nipple that's on the end here and nothing's happening, there's a good chance that the diaphragm inside the vacuum canister has seen better days. If you can always try to get the exact same one. Like I say, if you get one with, you know, 20 degrees advance on it at the crank and you're adding too much timing in there, and this is going to be the hardest part about these HEIs, is to get the correct replacement for vacuum canister. So if you're really good and you do your homework or get somebody that knows about it, they can get an adjustable one and set you up with a stop and everything if that's what you're looking for. But when you get to the performance part of this, there's a company or two out there that'll custom make these things for a race application or more, you know, you start stuffing in higher compression and, you know, heads, you know, you start putting in a lumpy camshaft and all that, and everything changes, you know. Your initial timing gets higher, even the way the carburetor works and, you know, reacts to what you're doing. So yeah, do your homework before you do anything, especially with ignition timing. The last thing you want to do, especially if you got some big dollars sunk into your engine as an investment, then oh boy, no thanks. Okay, there you have it. I've gone on long enough for this one. Hope you enjoyed it, folks. And until next time, be safe, take care, and have yourself a good one.